Hi everybody, this is the office hours for Algebra 1, so if you have any questions, this is the time to ask. You can either text me or email me or write a comment on this live chat and we can answer some questions. For those of you who don't remember, this is my phone number. Feel free to text me at any point, 724-566-3251. One question that I've already gotten from some people was number 10 on the packet number 2. It says the first 5 terms of a linear sequence are shown, and it gives you a list of numbers. 8, 6, 4, 2, 0. So if you notice, this is going down by 2. If you look at that problem, that is something that would indicate a slope of -2 every time. So I know if I'm thinking of a linear equation, that would be the m part of the equation. So y, I already know y equals -2x plus b. My job is to figure out what the b is, what the starting value is. Looking at the sequence, this is my first number, my second, my third, fourth, and fifth number. So if I want to go backwards, that will give me my b value. If I go back, and I ask myself what number -2 equals 8, that would give me that my b value is 10. Okay, so my equation is y equals -2x plus 10. And the question was asking, what's the 100th term in the sequence? So that means that you'd have to plug in 100 for x. You get y equals -2 times 100 plus 10, which is -200 plus 10. And we know that if we did that out, -200 plus 10 would be -190, which is answer B. I did get a lot of responses from other people in regards to giving your packet number 1. I do want to go over maybe 1 or 2 questions from packet number 1 or email me. My phone number is 724-566-3251. You can text me anytime, and I'd be happy to answer some questions, whether it's specific questions about a problem or if it is something in general, just a general concept. Great. So I think one problem I do want to go over from the packet that I think some people may have messed up on is number 14 from packet number 1. It looks a little bit like this: 5a cubed b. Okay, when you get to something like this, you generally need to multiply the numbers that are given to you. 5 times 5, which gives me 25. A cubed times a cubed is like saying a times a times a times a times a times a. If we just combine that all together, that's a to the 6th. Okay, and then b times b would be b squared. I saw some funky stuff on people's submissions. So please make sure that if you need to, you can expand it out before you multiply. All right, let's take a look. Still no questions? Feel free to tune in or text me at any point if you have any specific questions that you'd like to go over. Again, my phone number, 724-566-3251. Feel free to text me if you have any questions or specific problems that you want to go over. While we're waiting, I think let's go over one of the particularly tricky problems from packet number 2. Packet number 2 is due next Monday, so you still have over almost a week to complete it. But for those of you who need help, I'll go over maybe 1 or 2 more problems from packet number 2. All right, if we take a look at this first packet, let's do a combining like terms problem. I like problem number 6. Number 6, it says 5 minus 10x plus 4. The only things that are like terms that I can combine is the 5 and the plus 4. That's it. 5 plus 4 gives me 9. This minus 10x, I can't do anything with it, so I'm going to leave it as minus 10x. Okay, so the final answer for that problem, it's problem number 6 on the front of packet number 2. Next problem I want us to take a look at is, let's see, problem number 6 on the next page. it looks a little bit like this. And you do need to use some combinations of knowledge of exponents, as well as multiplication distribution property. All right, problem number 6. I have 4n cubed minus n times 3n. So you might be looking at this and you might wonder, like, if it's on the other side, you might wonder whether or not we still need to do distribution property. You do. Even though it's on the end, you're going to distribute to each thing on the inside. So you're going to do 3n times 4n to the third. I know 3 times 4 is 12. I know n to the third times n gives me n to the fourth. And then I got to do the same thing to the other term. 3n times n is 3n squared. Great. Hopefully this makes sense. Again, if you have any questions, please feel free to text me or email me. I'm checking constantly in case you have questions. So far, no one's asked anything, so please send them along, even if you want to just make sure that your answers are correct. Let's see. Let's take a look at number 18 on packet number 2. It's an MCAS question, and it's all about deciding what kind of pattern it is and using that pattern to predict the next number. So you see on your paper, it says, the table below shows a linear relationship between the values of x and y. So it gives you a table that looks like this. 1, 2, 3, 4. And the y values are 3, 9, 15, 21. Okay, so kind of before we were looking at whether or not to decide if something was linear, exponential, or quadratic. If I look at this and I want to decide, I really need to look closer to see if there's a rate of change going on. So to go from 3 to 9, I have to do +6. To go from 9 to 15, I have to do +6. To go from 15 to 21, I do +6. Awesome. Because I'm doing +6 every time, that means that this is a linear equation. Which means because I'm plussing 6 every time, in order to find the 5th term, I just need to do +6 again. So 21 plus 6, that gives me 27. Okay, so my answer for question number 18 on your packet number 2 should be 27. Okay. Feel free to send any questions that you might have. You should have my phone number, but just in case, it's 724-566-3251. Or you can email me. I'm checking my email pretty often. All right, let's see. No questions yet. Please feel free to send them along. Let's see. Oh, number 29. That's a really good one, actually. So it says the first term, and I'm looking at packet number 2, by the way. Again. It's talking about predicting what's happening in a sequence. It tells you the pattern that's happening every time, and it's asking for you to essentially describe what's going to eventually happen when you go further and further in that pattern. So I'm looking at problem number 29 right here. It says the first term in a sequence is 24. Each term in the sequence after the first term is equal to half of the previous term plus 4. So I'm going to divide by 2, and then I'm going to add 4. Divide by 2, add 4. So 12 plus 4, that gives me 16 as my next number. 16, divide by 2 plus 4, that's 8 plus 4, which is 12. Do it again, divide by 2, then add 4, so that's 6 plus 4, which is 10. Do it again, divide by 2, add 4. 5 plus 4 is 9. Do it again. 9 divided by 2 is 4.5 plus 4 is 8.5. Great. Divide by 2, add 4 every time. So if you notice the options that we have, A, the term gets closer to 8. B, the term gets closer to 12. C, the terms increase at a constant rate. Or D, the terms decrease at a constant rate. Well, I notice they're not increasing or decreasing at a constant rate. That would mean I'd have to plus or minus the same number every time. And that's not happening. There's like division going on and like it's not going down or up the same amount every time. So automatically C and D are out. For A and B, those are the only options we have left for number 29. The term gets closer to 8 or the term gets closer to 12. Well, it passes 12. The only option that we have left is that it gets closer to 8. And if I kept going with this pattern, it would indeed get very, very, very close to number 8. Okay. Great. So I think at this point, there's still no questions that are being sent along. If you have any questions or any problems that you want to go over, please feel free to send them my way. Do you see the comment that whether or not this is going to stay up? Because yes, I believe I will be saving this and I will be posting it. So if you don't have any time right now, please feel free to check in later on. I'll make sure to post this. Okay. Right now, and to answer the next question, which problem I'm showing, this one is packet number 2, and it is question number 29. I know these questions are in order, but in case you can't really see, it's question number 29 that I just went over right here. Okay. Please feel free to send any questions. If you have particular problems you want to go over, whether it's packet number 1 or packet number 2, please, please, please comment or send me a text. I'm answering any questions right now that you might have. Great. I'm going to bounce back to packet number 1, which is all about exponents. I know technically you already, you already should have submitted that to your teacher, but it's okay if you didn't. For those of you who might still want to just check your answers, for those of you who aren't sure, I will be posting the solution set so you can cross-check your answers with what you got compared to what I got. So I'm going to go over problem number 22 on the first packet. It looks like this one. Okay, we're going to go over that one. The problem they gave us is 4 f to the third g over 3 h to the 6th. And then they raise that whole thing to the power 3. There's a few ways that you can go about this problem. I like to always expand. So if I notice that there's an exponent somewhere, sometimes I like to just expand it to show myself what's actually going on. Because this has a tiny 3, that basically means that I'm multiplying this parentheses term by itself 3 times, okay? It's like doing this, 4 f to the third g over 3 h to the 6th times 4 f to the 3 g 3 h to the 6th times 4 f to the third g over 3 h to the 6th. Whoa, that's a lot. So you're multiplying it by itself 3 different times, okay? From there, it's really just figuring out what needs to be multiplied with what. I hope you remember when you first learned about fractions, and it's okay if you don't remember, but when you first learned about multiplying fractions, if I was given a fraction and I was multiplying it with another fraction, let's do 4. When it comes to multiplying fractions, you multiply the tops and the bottoms together. So for this example, 1/2 times 4/5, I do 1 times 4, which is 4, and 2 times 5, which is 10, so 4/10. I'm going to do the same concept here. I'm going to multiply all the tops, and I'll write it as my answer for the top. I'm going to multiply all the bottoms, and I'll write that answer for my bottom. Let's do the tops first. I notice that there's 4 times 4 times 4. 4 times 4 is 16, and 16 times 4 is 64. So I know automatically it's going to be 64 on the top. Then I'm going to multiply all my f's together. F to the third times f to the third times f to the third. That's like f times 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 f. So that's like 9 f's. I can rewrite that as f to the 9th. Okay? And finally, d times g, that's just g to the third. All right, the next part that I'm going to do is the denominator, the bottom. 3 times 3 times 3. I know 3 times 3 is 9. And then 9 times 3 is 27. Then I need to do h to the 6th times h to the 6th times h to the 6th. Hopefully you remember, when you're multiplying something that has the same base or the same letter, and you're multiplying it with exponents, you have to add those exponents together. So h to the 6th times h to the 6th times h to the 6th, that's h to the 6 plus another 6 is 18. Okay? I don't know if you can see this, but this final answer is 64 f to the 9th, g to the 3rd, all over 27 h to the 18th. That's the final answer for that one. In terms of, so I see a comment that's asking about the internet problem. I'm not sure what the internet problem is, whether or not it's you have access or your computer might be a little funky. I'm not sure if the school has been doing anything about that, but I do know that they're starting to set people up in the city of Boston with internet. So I think that if you receive the bulletin and include some information about like what, if you need to sign up for internet, I believe Spectrum is offering internet for free until like July 1st or something. So I would check in with Boston Public Schools or the city of Boston to help you with that. Otherwise, I mean, I know that teachers are being a little bit lenient about, working with students because I know that we are still adjusting. So if you have any issues with your Chromebook, with your laptop, with internet, just know that on our end, we are being very understanding and we're trying to, brace ourselves for people who are still kind of getting the ball rolling. Okay. Please feel free to send any questions. If you have any problems that you want to go over, here's my phone number again. Please feel free to text me or comment below. 724-566-3251. That's my phone number. Feel free to text me if you want to go over any specific problems. For those of you who are tuning in right now, just so you know, we did upload packet number 2, VL2, virtual learning number 2. So that includes the next week's topic, which is all about distribution property and combined like terms and knowing the difference between linears, quadratics, and exponentials. Okay, and we will be uploading the solutions for last week's packet. I'm going to be uploading the solutions today. So if you want to, feel free to check back on Google Classroom at some point later, and you can cross-check your answers. I also hope that people are doing the Desmos activities that we've been working on. We've suggested a few Desmos activities just to kind of keep the mode a little bit different. So I do see problem number 17 and 18 that we want to go over. Is this on packet number 1 or packet number 2? I'm wondering. Packet number 1 or packet number 2? 17 and 18. All right, it must be packet number 1. So let's take a look. Awesome, thank you. So let's take a look. 17. Oh, this is a really good one. Thanks for asking. -5 x squared y times 3x to the 4th. All right. So anytime you see a number in front, we call that a coefficient, just in case you weren't sure. That's okay. Just in case you weren't sure, these are called coefficients. They're numbers. And whenever you have numbers and letters together, in general, when you're doing some multiplication, we multiply the numbers with the numbers and the letters that are the same with the letters that are the same. So I notice that there's a -5 and a 3. -5 times +3, that's -15. Hopefully you're okay with that so far. The next thing I want to notice is that there's an x squared here and an x to the 4th. If you want to, you can also, I'm gonna backtrack. Instead of multiplying the coefficients first, let's actually expand all of this out so that you can see where the answer is coming from. -5 x squared y. That's like doing -5 times x times x times x. Hopefully you're recognizing that the exponent comes from how many times you're multiplying it with itself. So x squared is x times x. X to the fourth is x times x is 4 times, okay? From here, you can kind of multiply and combine things so that you have just one little x and one little y. Then we're going to do, I notice that there's x times x times x times x times x times x. If you count, that's 1, 2, 3, 4, 5, 6 x's being multiplied together. So because there's 6 x's being multiplied together, I can re-represent that as x to the 6th. That's what exponents do. It's representing that whole string of x's being multiplied together by writing just a single x and the number of times it's being multiplied together. Finally, I'm going to check to see what other y's are available or what other y's are being multiplied. It looks like there's only one little lonely y, so I'm going to do x to the 6th times y. So my final answer for number 17, negative 15 x to the 6th y. Hopefully that makes sense. We're going to move on to number 18. This is still in packet number 1. Number 18 is a very similar problem. It's multiplying. I'm going to try the same approach of expanding everything and then simplifying based on that expansion. You don't always have to do that. Sometimes there are people where after enough practice, they remember those rules and they don't have to expand it. If you're not at that point, that's okay. So taking a look at number 18, I have, looks like this, 2ab squared f squared times 4a to the 3rd b squared f squared. So if you take a second, I'm going to do the same process. I'm going to expand everything out, and then I'm going to multiply and see if I can combine things, okay? So this first term, or this like first parentheses group, I'm going to expand it out. 2 times a times b squared, which is the same thing as b times b, times f squared, which is f times f, okay? Then I'm going to multiply it with this expanded. So times 4, and then a to the 3rd. That means I'm going to do a times a times a. I'm going to do it 3 times. A times a times a. Times b squared, which is b times b, and f squared, f times f. All right, I'm going to try and switch up some colors so that you can see where everything's coming from. All right, so hopefully you notice we're a whole thing. You thought A and B were a whole thing. No, they're actually separate. If they were, if it looked like this, if we had AB squared, if it was in parentheses, that would be a completely different story. But since they're kind of all together, there's no parentheses grouping the A and B together. We don't group them together. We wouldn't do AB times AB, okay? So 2 times A times B, we have this whole thing expanded out. I noticed that the 2 and the 4 multiply together to give me 8. And now's the fun part. I get to count all the A's, I get to count all the B's, and all the F's. If I take a look, there is 1, 2, 3, 4 A's. 1, 2, 3, 4 A's. So that means A to the 4th. And now we get to count the B's, which is fun. The B's, there's 1, 2, 3. There's also 4 B's, so B to the 4th. And then finally, I'm going to count the F's. 1, 2, 3. There are 4 F's, so F to the 4th. Whoa, that's a coincidence. That I don't want people to think that this happens all the time. The fact that their exponents are the same is just a coincidence. That doesn't happen all the time. Great. So our final answer is 8 times A to the 4th, B to the 4th, F to the 4th. Cool. Please feel free to send any questions or any problems that you want to go over from packet number 1 or packet number 2. Again, my phone number is 724-566-3251. Feel free to text me. If you're not a texter, that's okay. You can still comment below, and I'm happy to go over any problems that are sent my way, either from packet number 1 or packet number 2. Packet number 1, I am going to be posting these solution sets live in a little bit. So if you are pretty good about packet number 1, really a majority of this time is spent for packet number 2 if you're having trouble with that. I guess one thing I could go over real quick that some people have questions on last week related to the Desmos activity was how to write an equation for an exponential if you are looking at the graph, and vice versa. So if I asked you, or if I gave you some information about something that was exponential, you would need to identify some of the information about that exponential. Okay, what I mean by that is this. So if you're given a graph and you know it's exponential because it looks like a curve, you want to identify a few things. First, you want to identify the starting value. And if you remember in the equation, y equals a times b to the x, the starting value is your a. Then you want to look at how fast it's changing. So is it doubling every time? Like, am I doubling in height every time I move along? Or am I tripling in height? Whatever the rate of change is, that is your b value, okay? So for example, if I knew that there was a graph that started at, let's say it started at like 3, and let's say that every time that it went up twice the amount, so my next value was 6, the next value was 12, the next value after that was 24. When you're looking at each of these points, or when you're looking at a graph and you're noticing that it's doubling every time, that would be the hint of what your b value is, okay? And since my a value, my y-intercept is at 3, I know my a is 3, my b is 2, so the equation for that graph would be 3 times 2 to the x. Okay, so for those of you who weren't sure how to look at a graph or how to identify what the issues were, or how to look at the equation from a graph, this is how you would find it. You always want to find the y-intercept, and then you want to look at the rate of change, or how much it's increasing by every time. Great. Similarly, if you were given an equation and you had to make a graph from it, and you know it's exponential, it's actually pretty easy to do. Okay, so let's say I gave you an equation. Let's say my equation was 3 times 2 to the x. Oh, that's the one I just did. Let's do 4 times 1/2 to the x. Let's do a fraction. In order to help you set this up, you can think of a few things. First, you'll want to look at the b value. The b value is 1/2. You have to ask yourself, is that greater than 1 or less than 1? This b value is less than 1. So automatically that tells me if I have to choose between growth or decay, this is going to be a decay graph. Hopefully, if I do it correctly, it'll look like a decay graph, which means if I'm plotting my points, that the points will go downwards. Okay, let's start with, we're going to start with 0, then 1, then 2, and then 3. So if I start at 0, that means I'm doing 4 times 1/2 to the 0. Math fact, if anything is ever raised to the 0 exponent, that's going to be 1, always. So this is like saying 4 times 1, which equals 4. Okay, so I know that I have a coordinate point at 0, 4. If I do the same thing with the next one, 4 times 1/2 to the 1, anything raised to the first power is just itself. So 4 times 1/2, which equals 2. So my next coordinate point of my graph is going to be 1, 2. My next point is 4 times 1/2 squared. Anytime that you're squaring a fraction or you're raising a fraction to any exponent, you're multiplying the numerator and the denominator by itself that number of times. So this becomes 4 times 1/4, which is just 1. Okay? And the next one, 4 times 1/2 to the third equals 4 times, and then my fraction, 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So 4 times 1/8, that's just 0.5. I know that might be a little hard to see, but my final coordinate point is 3, 0.5. On a graph, here's what it would look like. I'm just going to plot those points. 0, 4. 1, 2, 3, 4. 1, 2. 2, 1. 3, 0.5. Cool. It works out. It's definitely a decay. That's pretty cool. So luckily, I noticed my B value was less than 1, which means that it's decay, and my graph, luckily, shows that as well. And on the table too, notice the numbers keep going down, 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 and it's going down by a consistent ratio, which means I'm dividing it by the same amount. Great. So I see another question that says, I'm confused about the notes between monomial and polynomial equation. Oh, great. That was, you're jumping a little bit ahead of the curve for that one. So in terms of that packet with the notes, monomial, polynomial, etc., we want to just give you a taste of what it looks like. That stuff, that terminology, you're not going to really need to know too much at this point. That's more of Algebra 2 lingo. But I'll clarify because, I think it's helpful to get that information. Okay, so monomial is, if you notice the prefix mono, you might be able to figure out what that prefix means. It means 1. And nomial is terms. So 1 term. What that means in math is that you have an expression, which is things with numbers or variables or both. And because this is a monomial, it has just 1 term. So an example would be like 3x squared. Or another example, x. Or 2x. It's just one thing. There's no pluses, there's no minuses, it's just one thing. Another term you might hear is binomial. The prefix bi means 2, and nomial meaning terms. Some examples of binomials is 2x plus 1. You see how there's 2 parts to it with a plus or a minus in between. Another example is like negative 5x squared minus 3. See how there's 2 separate parts. Binomial, 2 parts. Then we have something called a polynomial. And poly is just a blanket term, an umbrella term that just means many. So many terms. It's kind of like once we get past the 1 and the 2 term things, we just call it polynomial. Okay? And it just means that it's 3 or more things with pluses and minuses in between. And when I say that there's pluses and minuses, 5x squared plus 2x minus 1, for example, I can't combine any of these because none of them are like terms. This is technically a polynomial. But the whole point is that monomial means that there's just 1 term. Binomial means that there's 2 terms that you can't combine, like there aren't like terms, they're as simplified as you can get. And polynomial is just the like everything else. There's 3 or more terms. And in terms of the other notes from that section, it was really just to get you exposed to the different types of like math terminology that you'll see. So in terms of monomial and polynomial, it's just when you're adding and subtracting things together, that there's variables involved, numbers involved, but it's just the number of things in that expression. And the reason why we did that is because when it comes to the distributive property, sometimes people forget that when you're doing distributive property, you are multiplying everything by like the thing that's being distributed. As I know, that sounds really weird, but let me give you a nice little example. So for example, if I had something like 5x times x squared plus 2. When we talked about monomial and polynomial, it was just, trying to figure out like what we would call these things. This thing that's being distributed, that's a monomial. And then this thing on the inside, that's a binomial. You don't really need to know that, but sometimes it's just easy to know what the terms are so that you know what's happening. I'm going to distribute 5x times x squared is 5x. X times x squared is x times x times x, so x to the third. And then 5 plus 5x times 2, which is just 10x. So if I were to ask you, like, what kind of answer what would you classify your answer as? This would technically be a binomial. You could loop it in as saying a polynomial. Technically, poly means many. So you would say that this is like a polynomial answer. And if I wanted you to go further, you would say it's a binomial. It's a type of polynomial. What we're hoping that at some point, maybe after April 27th or maybe even later, like whenever we see each other again, we're hoping that you can get to the point where you do something like this, where you're multiplying two binomials together, which we haven't really done this before. You haven't done it in Algebra 1, and I'm guessing that you haven't done it in like 8th grade math when you've learned this kind of stuff. But when it comes to these kinds of advanced problems, you would take the first thing in the binomial and multiply it with everything, or distribute it with everything in the second one. So you do x times x, and then x times -2. So plus x times -2, plus, and then you would do the same thing with the other number in that first term. 5 times x plus 5 times -2. So x times x, that would get me an x squared. X times -2 is just a -2x, same thing. 5 times x is just 5x, and then 5 times -2 is -10. From there, that's when you combine like terms. -2x and 5x can definitely combine. You cannot combine the x squared with anything because there are no other x squares here. So your final answer would be x squared, and then -2x is not something that we expect you to know right now. This is like an advanced level of multiplying polynomials or multiplying things together. It's the like next level of distribution. So don't worry if you don't understand this. That's okay. We're going to get back to this when we come back from this coronavirus break. Okay. Let's see. On packet number 2. Is there more than one monomial and binomial? Yeah. So when it comes to polynomials, it's basically when you can't combine any more like terms. There's no other like terms left, and when you have more than like 1 or 2 terms, when it's like, I usually qualify it as 3 or more terms. So this would be a classic example of a polynomial because I can't combine the x squared with anything else. I can't combine this 3x with anything else, and I can't combine this -10 with anything else. So because there is 1, 2, 3 parts, that technically qualifies as polynomial. Exponent problems, like practice problems from the first packet. We've looked at some practice problems from the second packet. I've just been answering some questions. So if you have a specific question that you want to go over, please feel free to leave it in the comment, and I'm happy to go over it. I'm also going to try and save this video so that I can post it for you to see. Either comment on a particular question that you want to go over, or you can just text me, 724-566-3254. And I also do want to mention that if you are someone who really wants to check your solutions, make sure you're doing everything okay, I will be posting the solutions to packet number 1 later on today. So you can always just cross-check your work and look at my work to kind of see what's going on. So feel free to leave quadratic. We'd like to go over the quadratic equation, please. Is there a specific piece in the quadratic equation that you'd like to go over? Like, in other words, is there a specific Is there a specific part of the packet that you'd like to go over where you've seen the quadratic equation? Oh, I think I see what you mean. So related to the quadratic section, a quadratic equation is it follows the form, and I know that I threw a bunch of letters in there. Right, so in terms of the quadratic equation, I wrote in the notes quadratic is when it's ax squared plus bx plus c. You've seen the a, the b, and the c before. You've seen them as like letters. When it comes to the quadratic equation, a, b, and c, we use to just represent that there would be numbers there. So an example would be like 2x squared plus 7x minus 3 is just in place of numbers. And the quadratic equation is just, it's a format of writing it's a format of writing an equation. Kind of like how in linears, we write it as y equals mx plus b, where like the m and the b were numbers. It's the same concept. A, b, and c are all numbers. In terms of the table, yeah, I'm happy to answer that question. So in terms of a quadratic table, if you didn't get a chance to see my video about comparing quadratics with linears and exponentials, the table is probably the easiest part to tell whether or not it's a quadratic, but it takes a little bit more work than the other things. Like it takes a little bit more work to see if something's a quadratic based on the table compared to like the graph or the equation. Let me give a quick example. So negative, I'm just going to use the example that they gave on here. -1, 0, 1, and 2. Okay, so they gave this information on the table. -6, quadratic. You want to go through the list in that order as well. You want to ask yourself, like, is it linear first? If it's not, then see if it's exponential. If it's not, it's probably quadratic, but we'll prove it. Okay, so to decide if it's linear, remember, you need to be adding or subtracting the same amount every time. So in order to go from one number to the next, I have to either add or subtract the same number every time. Automatically, not linear. Automatically, because that rate of change isn't the same. Okay, so we know it's not linear. In order to decide if it's exponential, I have to see if I'm multiplying by the same amount every time. In order to go from -6 to -6, I would have to multiply by 1 because it stays the same. In order to go from -6 to -4, I think I have to multiply by 2/3. Multiply by 2, then divide by 3. So -12 divided by 3, yep. Automatically, because this one is multiplying by 1 and this one's multiplying by 2/3 to get to the next number, automatically, or divide. Automatically, because it's not multiplying or dividing by the same amount every time, it's not exponential. The last one we have to look at is quadratic. Here's how you check quadratic. You start very similar to what you did for linear by figuring out what you're adding or subtracting every time the first go around. So to go from -6 to -6, I have to do +0. To go from -6 to -4, I have to do +2. To go from -4 to 0, I have to do +4. To go from 0 to 6, I have to do +6. Okay, again, we know it's not linear because those numbers are not the same. However, you might notice in these numbers, 0, 2, 4, 6, you might notice that those numbers go up by the same amount. For 6, I have to add 2. We call this first one, when we're looking at the differences, we call them the first difference. If the first difference isn't the same, it's not linear, okay? But sometimes if you look at the next layer of that, the second difference, if that number is the same, which for this example it is, that makes it quadratic. You have to look and make sure that the second difference is the same. If it is, then it's quadratic. we like to say, like, if I asked you, if I gave you a question that was asking, like, is this length, the second difference is the same. Okay? That's all you need to say. That the second difference is the same. I hope that clears up some stuff. Feel free to send any questions that you'd like to go over. I'm looking at both packet number 1 and packet number 2. So if you have any questions on any of those, send them my way. In case you forgot, my phone number is 724-566-3251. You can text me or you can comment on my YouTube video in case you want to send any questions or problems that you want to go over. Graph. I don't want to jump ahead too much because in advanced algebra, the class that you're going to take next year, we go way into depth with that. We don't really have, right now, we don't have the tools to figure out, how to graph it exactly, other than creating an XY table. So like if you're given the equation x squared plus 2x plus 8. If you were given that, I would just off the bat, I would say, hey, make an XY table. Go from 0, maybe jump to 2, 4, 6, 8, whatever you want to do. You would plug in the x values and solve it and write the answers here. No matter what, like assuming that you do your table correctly and plug in correctly, your graph will look like this. And I don't know if you've been taught yet what this is called. If you haven't, it's okay, because we really haven't learned too much about this kind of quadratic thing. But this graph is called a parabola. Kind of like how a linear equation makes a line, we call this shape a parabola. It's one of my favorite math words. There's another math word that you'll learn later on in advanced algebra, or in algebra 2. That's also my favorite math word, but the shape of this parabola, x values, solving it, and then writing the answers as coordinate points. So for example, if I have x squared plus 2x plus 8, if I plug in 0, 0 squared, that's 0, plus 2 times 0, that's 0, plus 8, plus 8, 16. If I plug in 4, 4 squared is 16, plus 2 times 4, which is 8, so 24, plus 8 is 32. Well, it's getting a little too high for me to calculate that. And yeah, it does kind of sound like nebula, but parabola is how you'd say that graph, that curve. This goes on and on, and the numbers are going to get super high. Once you kind of graph it, I sketched my graph, but this graph that I drew is actually not correct for what this equation is. That equation would probably look something like this. It's a U shape, we call it sometimes, like a U shape or a horseshoe shape. But it would intersect my y-axis at 8. And right here and right here, you're going to learn eventually how to find out what those x-intercepts are as well. For now, we're kind of getting way ahead of ourselves. You really don't need to know this as many questions about this stuff. Other than occasionally you might be asked like what these are and what this is, like what the intercepts are. But at this point, all you need to know for our class right now is just how to decide whether or not something is a quadratic based on its equation and based on the table. Okay, and like I said, at the table, you just look at the second difference. In an equation, you want to make sure that there's an x squared. Oh no, don't worry about asking too much. If anyone has any questions, please feel free, send questions my way. I'm going over any problems you might want to review. I'm going over any questions you have in general about the notes or about the packets. Any questions, please feel free to send them my way. All right. I think I'll go, I have a little bit more time left. I have about 8 minutes left. I'm going to go over maybe one more problem. I like to go over a division problem from packet number 1. So sorry, I'm bouncing back to exponents. I'm looking at number let's see, number 16 on that packet. So it looks like this. I'm going over this one next. Looks like a exponent. Sometimes it just helps to break things down so that you can kind of see everything panned out. Over 10 times x times, and then 5 y's. 1, 2, 3, 4, 5. 10 times 3 x's and 1 y. When it comes to looking at fractions, don't be frightened. I think one thing to kind of keep in mind is that when you have something that's both in the numerator and the denominator, you have the opportunity to cancel stuff out. Here's what I mean by that. If I told you to reduce the fraction 2 over 2, if I told you to simplify that, you'd probably say, oh, well, 2 divided by 2 is just 1. And I would say, yeah, you're right. That's the same concept. If you have something on the top and on the bottom, that's so packet number 1, VL1, I'm looking at problem number 16. So because if we have something on the top and the bottom, because it simplifies to 1, you can use that same concept. You can use that same concept with variables as well. So if you notice, if I have an x on the top and on the bottom, I can cross 1 off on the top and 1 off on the bottom because technically that simplifies to 1 whole. Okay? And then I can do the same thing with any other x's I see that cancel out, 1 on the top and 1 on the bottom. I think there's only 2 x's that would cancel out on the top and on the bottom. After that, I can move on to the y's. I think there's only 1 y on the bottom, so I can only cancel out 1 y on the bottom and on the top, and that's it. Once you get to that point, we can kind of simplify a little bit more. I'll write what we have so far. So far, we've reduced it to 15, and then y times y times y times y, 15 y to the 4th, over 10 x. That's all that's left. I were just telling you to look at 15 over 10 and asking you to simplify that. You might notice that 15 and 10 can both be divided by 5. That's a great point too. Yes. I'll talk about subtracting the powers as well. So 15 and 10, if I divide 15 by 5, that gives me 3. If I divide 10 by 5, it gives me 2. So my final answer is 3y to the 4th over 2x. I love the point that you just made, that someone just made about subtracting the powers. That's definitely true as well. If you notice, x to the 2nd over x to the 3rd, the 2 and the 3 is 1, which gives me y to the 4th on the top. It's great. Yeah. Using those laws of exponents is definitely something that you can have in your back pocket to kind of cut all of this out. If you feel that this is all unnecessary, I'm with you, but sometimes it's helpful to visualize it. If you already know and are starting to understand the laws of exponents, absolutely use those laws of exponents instead. It saves you a ton of time and a ton of space if you're someone who's beyond that point. I think I might have time for one more question if anyone has any questions you'd like to go over. Are there any problems that you'd like to go over? I'm looking at either packet number 1 or packet number 2. I'm fine with both. All right, well, if no one has any other questions, I think I'll just pre-select. I'm looking at packet number 2, VL2, packet 2. I'm looking at number 8. It looks like this. Okay, so last problem I'm going to go over, it looks like this. Z times 2x plus 4y plus z. Okay. Remember, laws of exponents are only used whenever, I'll go over question 14. I can do that after. When it comes to exponents, you really can only do that if you're using the same base. You'll notice z times 2x, z times 4y. This is a z, this is an x. You can't do any exponent stuff with that one. So this becomes 2xz. If you wanted to do 2zx, that's also fine. The order doesn't really matter. I'm just a little bit, that's up to you. Then z times 4y, that's 4yz. Remember, we can't really do anything with exponents because this is a z and this is a y. Then the last one is where we actually get to, because this is a z and this is a z. Z times z gives me z squared. So my final answer for number 8 on packet 2 is 2xz plus 4yz plus z. 14. Was this on packet number 1 or packet number 2? I'm wondering. Let's see. I'm assuming it might be packet number 2. Packet number 1. Okay. So packet number 1, number 14. I'm assuming it's this one right here. Great. So the last one that we'll wrap up today's office hours with is number 14 from packet 1. Number 14 is 5a to the third b squared. There's 2 ways to go about it. I'm going to go over the long way, then a way that might be very annoying to some people, where I'm going to expand everything out, and then I'll go over the power, the rules of exponents way. So 5a to the third b is the same thing as 5a to the third b times itself twice, 5a to the third b. From there, you can do 5, I'll expand it out, 5a times a times a times b times 5 times a times a times a times b. From there, 5 times 5, that will get me 25. A times a times a, and then I notice there's 3 more over here. Total, there is 1, 2, 3, 4, 5, 6. There's 6a, so a to the 6th. And then b times b, which is just b squared. I'll give you a shortcut though. If you were looking at this and you hated this way, which I don't blame you, it takes a lot of time and a lot of writing. If you wanted to do the shortcut way, anytime you were squaring anything, it's kind of like you're squaring everything inside, but you can only do that if everything on the inside is being multiplied together. So that's like saying 5 squared times a to the third squared times b squared. This a to the third squared is where the rules of exponents kind of play a role. 5 squared, we get the 25. A to the third squared is like a to the third times a to the third, which you can just, we know that's going to be a to the 6th, but if you ever have an exponent you raise to another exponent, just multiply them. That's what the rule says. So we get a to the 6th, and then b squared is just b squared. So either way, up to you. You can either expand it out or you can follow some of the rules that were given with exponents. For now, though, it's just over the hour mark, so I'm actually going to be ending my office hours. Yeah, it is great to use that shortcut because some numbers are really way too big. So hopefully you've learned a few things about either exponents or our next topic, which is all about distribution and about quadratics. If not, please feel free to email me or text me at any point, and I'd be happy to answer your questions. Otherwise, I hope everyone is safe. I miss everybody. I wish we could see each other every day, but I think it's better that you and your family are safe. Feel free to stay in touch, and I hope to see you at some point soon. Bye.